got this to work on to try to figure out what's wrong with it. And it gets worse because I have another one. My hopes here is to take one that was completely trashed when I picked it up, as you can see, and another one that doesn't work, and hopefully make one, maybe one that is fully functional. Okay, you have been replaced. Success. Hopefully you flashed on enough over here. Yes, you did. Okay. So you're doing exactly what you should be doing. You're supposed to be doing. Except for that LED display. Already gone through all the sliders. I know they're working. I know all the inductors are working. So I don't think it's a problem with anything other than the LEDs. I know I have to clean some pots and everything. It's getting signal in just fine. Connections in the back need some work, but there it is on that signal. Okay, so why do I have bad connections everywhere? Something going on with the power cord. Yeah, so you need a new power cord. Yep, it went out again. Yeah, so it needs a new power cord. That's a given. Well, I got a donor for that. So there it is. I got signal going in. Let's do some fishing around here. So you should be here and there. Okay, that's the gray wire, right? Gray and black. So if I go here, go there, I should get my signal, and I do. If I go here, I should get my signal, and I do. That's that wire. So all the wires. You should be signal. You're sure as hell not. So wait, let's test this side, compare it to the other side. Okay, here I am having fun. Having to take a deep dive in this just to figure out why the LED meter isn't reading right. I think I've narrowed it down to a potentiometer, maybe, but I'm not sure yet. It could just be the potentiometer on the front of this unit. So I'm going to clean it, see what happens, because the other side calibrates just fine, but the left side does not. And according to this, shouldn't do that. Well, I have removed the pot just to see if I can, the donor, to see if it's the pot in this one. Plus, I went ahead and did the main chip that does the signal comparing. Apparently, that's what does the LEDs too. So I'm just shotgunning at the moment. Yep, it ain't chip. Because that's the same behavior. So potentiometer. I don't have to take the potentiometer out. That's hard. Well, 207. I could try capacitor 207. That's another possibility. Let's see here. Where'd you go? Where did I read that earlier? It could also be a bad 208, according to what I'm reading here. But why would 208 work on one side but not the other? Let's give it a shot. I was going to recap it anyway. Well, that's a good thing. Seriously, you're not coming up. Why not? Plus goes up, negative goes down. Slowly working my way through that part of the circuit. Y'all are replaced. We try again. And still going on. What ain't that? Interesting. I guess it could be the variable pot. Doesn't make any sense to me, though. So it wasn't those two capacitors. This is all power. The signal's getting through fine because I can adjust everything. It's not the comparator chip. Still could be the pot. It still could be 208 for some reason. Let's take out variable resistor. Let's take that one out and see what happens. So variable resistor 3 is this one that sets the one of those channels. It sets the left channel, which is the one that's yelling at me. Okay, it is 5 and 3. 5 and 3 5 and 3 are the left channel variable resistors. So 5 and 3. So 3 and 5. So the outer ones are a problem. Take 3 out first. Variable resistor 3. That is this. And that should remove this guy. And it does. And that did nothing. Interesting. That should isolate that entire side. Okay, has nothing to do with potentiometers. At least those two. Those are the adjustment ones. Interesting. What could it be? I don't understand. Well, y'all are doing exactly what you're supposed to be doing. Somebody's been in here before. Is there any sort of weird short anywhere? That seems fine. Well, you've been resoldered for some reason. You've been resoldered. Not by me. I worked those. It's been redone. It's been redone. Stuff's been done down there. Yeah, somebody's tried to fix this already, which is interesting. Okay, just out of kicks and giggles, let's make sure it's doing the stupid stuff still. It is. Let's take out 208. Why not? That is the one, supposedly, that is the one. So, let's see what it does. If I take it out. Now, this fella right there. Supposedly, this is the one that drives everything down. These run the other LEDs. Because there's 1, 2, 3, 4, 5, 6, 7. I wouldn't think that would be the case, but do it anyway. Okay. The chip puller. Where's my chip puller? Oh, yeah. I gave it to somebody to borrow. When I need the chip puller. There you go. That ain't it. That is the 12th. Okay, that does do the 12th one. Okay, so you're getting a bad signal somehow. Because that knocked out the bottom one like it's supposed to on both sides, I bet. Okay, so that actually tells me that's working. So all the chips are working. It's getting a bad signal. It's getting a bad signal from something. What? I don't know. I'm going to have to stare at the service manual some more. It has nothing to do with you or those chips, which is perplexing to me. Back to the schematic. Okay, now I'm just poking around. Okay, it wasn't you two guys. I don't think it's any of you guys. Is it getting hot? If I touch that, that's the other one though. That's the one that works. So weird. So it's that side, and it's when it's coming out of there. So let's look at the circuitry of that part. Could I have blown all the flipping diodes? 0.6. Okay, so you should read 0.6 here. And you sure as hell don't. You're reading the 1.8. You're reading 1.8. You're reading 1.8. So you all are going to be 1.8 over here too. 1.8, 1.8, 1.8. Okay, interesting. So, what should you be reading? So are all the diodes kaput? Okay, back it up one more. So all the diodes are getting 1.8 volts. Let's see, so you would have been this one. So y'all are just running high. So what are you supposed to be doing? Those are all the same. Can't fathom one side of the things are working and the other side isn't. Wouldn't think that's possible. I am lost. That ain't gonna be it. That might as well keep going anyway. Don't understand. I am very confused. Okay, all the middle works. All the middle works. So that pot works, that pot works. This is fine, that's fine. It has nothing to do. It's just getting a high signal because all of these are reading 1.8 volts, which is turning on the diodes. Why would they all be turning on? That's right. Holy crap. I've made progress. Cool. Wait. That's closer. That's closer. I've made some progress. Why? I don't know. That's the closest I've gotten. And now it's responding to this now. Sort of. I have actually made some freaking progress. So those caps did do something. They did do something. Well, that's a good sign, at least. I'll just keep going. Why not? Like somebody's been here before me doing exactly this, because I didn't mess with that one yet. Eventually, I'm going to get this camera stuff figured out. We'll go back and forth between this one and this one to get readings. 0.6, 0.6. These are all going to be 0.6 again. 0.6. 0.6. So something over here changed. I just can't get the last three. 1, 2, 3. Why are those still up? I'm still working my way through the schematic here, trying to figure out where it's going wrong. I have not figured it out yet. I've been slowly checking through various places. These are the ones that are trying to stay on. Kind of split. These are the diodes trying to stay on. Those now 3 are just always on no matter what I do. Trace them down here to these things. And I've been doing a little bit of back and forth, try to see various differences in readings, and I haven't come across anything yet, so I'm a little perplexed. But these are definitely just getting a solid reading of voltage. Yet everything I keep measuring seems to be fine. So I'm confused. I'm going to start checking these diodes, I guess. Yeah. Meanwhile, I'm shotgunning a few things as well, just to see if it makes a difference, because it's stuff I'm going to do anyway. Oh, interesting. Okay, it switched that time. What's it doing? Yeah, that side switched it fine. That side, not so much. You should change too. You're not. Not. Got another potential. It might be in the meter switch. Seems like one side of the meter is switching and the other side isn't. Something else to figure out. Slowly working my way through various and sundry possibilities. Still looking over this entire thing, thinking somebody's been here before me trying to figure this same thing out. Because they've reworked the switch solder, clearly. This was me. That was me. That was not me. This was not me. That wasn't me. So somebody has slowly tried to find the same issue. That wasn't me. I'll get there. It's just going to take me a while. I mean, it works regardless because it does what it's supposed to. It's just that meter doesn't work. And I don't want that. I want the meter to work. I guess I could just reflow every bloody thing. See if it does any good. Okay, let's tackle the power cord issue. Because the power cord issue is an issue. Okay, you are the black. That one, so you're the white. Okay, first things first. I need to get you out. It's often easier said than done. Yay! That was glued. That's why it was so hard. It was also glued in place. Bad connection here somewhere. Can't see it anywhere. Okay, trying to find where this strange voltage is coming from. Here? No. But it's definitely here. Which is here. Which is not there. But again, it's, where are you? Here. and it's not there. You're doing what you're supposed to. But you go here, you're doing what you're supposed to. You're just not the right voltage. I am so confused. If I take you out, you don't care. I'm going to take you out anyway. Let's try it again. I've replaced that capacitor. Replace this one. Made no difference. These are too high because, and that goes in here and that's too high. That's not doing anything, but you get a voltage. Just not getting the right voltage. This is definitely adjusting something. Have I ever taken that out? I have not. Take it out. Will that do anything? If I take that out, there will be no connection across it. So there'll be nothing here. There'll be no voltage on 201. But I take this out and those lights go out, I will have at least traced it back to here. If that's not the issue, it could be back over to this way to pin 48. What is pin 48 supposed to be? Pin 48. Pin 48 is supposed to be round. Is pin 4. That would be interesting because that would be the, but that's okay, but that's working this over here. So that's going to be ground. Oops, there, that's the ground reference for this. So that's the variable part. So this is the high part. So ground seems to be working. Yeah, ground seems to be working on both of these because this one works. So that adjusts. So it would be that it's whatever wherever this is coming from, which is 9 and 28. 28. And then let's see, 28 on that side. 28 on that side, which is switch 3A up here, which is that part of the branch. So there's our 201, which is supposed to go to ground through variable resistor 201, which is that. Yep. So variable resistor 201, 28, and 29. So 28, if 28's getting something wrong, it's because the variable resistor of this guy. Take you out. Let's try it. So have I finally dragged it down to this? I know if I take this out, these should go out regardless. Because that powers here and goes to the switching to here. Unless something here getting fed in wrong from the left channel. So let's hang on. So 28. What was 28? Okay, 28 is this guy here. 28. How would there be voltage over there? 277. 28, 29. 28 and 29 get stuck together. Pin 49. And pin 49. Yeah, pin 49 is supposed to be. Where are you hiding? You over here? Pin 49 is supposed to be for the jack. Doesn't really help me any. That makes sense to switch there. Okay. Yeah, that seems to be doing what it's supposed to. So I'm a little confused. Okay, so 1, 2, 3, 4, 5. See, that's nothing. That's nothing. There's 3 something. There's 3 something. There's 0. 3.3. That's interesting. What is that one supposed to be? 1, 2, 3. That's 31. That's to the wrong side. So you're still, yeah, you're getting fed the wrong information. 31 and 32. That's a little suspicious. So that is a bad reading compared to the other side. Yeah. So you're getting it from here. So where are you? You are, yeah, you're the bispec switch. 33, 32, 31. The bad one. 31 is here. And it goes to, yeah, it goes to all the bottoms of there. So that's, again, that's getting a wrong reading. Troubleshooting. Trying to find out which part is misbehaving. But I'd already checked you. Yeah, again, with you out, nobody touching there, nobody touching there. with you out, none of these lights should come on. And they do. I don't understand. Where are you even getting a voltage? And you were, that side's fine. This side's not. It's still just getting that strange voltage. So there shouldn't be anything there. There's 4 freaking volts. 49, we're at 48. You should be ground. And you are. Voltage. And you are. 1049. You're fine. Ground. See, it was, yeah, it's on the outside. So this guy. Are you ground? No, wait, you shouldn't be ground. You should be, this should be ground. Pretty much ground. You should be ground. It's pretty much ground. You should be ground. Oh, that's the supply. So that should be 5 volts. It should be 5 volts. Yeah. That's 1.1. That's 1.1. That, you guys are absolutely freaking doing your job. That is doing its job. This is doing its job. You are doing your job. I am so lost. So let's see. Y'all should be about 0.6 volts. You are. And you are probably too high, like 1.8. All those are just too flipping high, so you can't turn them on. Not the chip. Not that. Why did you even stay on? Now we stare at this until inspiration strikes us. The inputs on this side of the circuitry is getting too much. The references are fine. References are fine. Supply is fine. Those are all measuring fine. Those two are measuring high. 201, which is now up here, is measuring a voltage on this side. All this 201 again. 201 goes to the capacitor. On mine, it goes to the capacitor and then 201, but here we go. So that's here. So that's too high. So this is too high. So this is too high. So that's too high. Is it the chip? Is it coming in this way? No, but that's the voltage it's trying to read. So that's the signal. That's the signal going that way. That's the voltage here should be like the voltage here. Change those capacitors. Okay, so whatever, this voltage should all be the same on that side and this side of 225. Let's start breaking this freaking thing down. So R226 and 225, that's this guy here and that guy there. So the voltage there on this side of it be the same as the voltage on this side over here. And it absolutely is. So that there, the voltage there, nothing. The voltage here, nothing. On the other side, too flipping much. Okay, on the other side, pretty close to nothing. So that tells me the problem exists here. So the voltage on this would be the same as the voltage here. So on R210 and 209. So R10 and 4 volts. Okay, so that's flipping too high. Sends a signal to, so that's too high. Okay, let's try that again. Okay, too high there. So 203, too high. 204, low. Okay, so let's follow 204 and see where you go. So if it's too high here, it's juicing that, then that should be fine. So the inside things are fine. So 4 volts is way too high, I think. Nope, 4 volts. Okay, so that is the same. 6 volts, 5 volts. So a little different. E203, 7 volts. E204, 5 volts. 4.5. That's fine and that's fine. I am so freaking lost. Why not? I have another one of these chips, and I just can't for the life of me. Both of these chips would have the same issue if it wasn't something in the circuit. Take one out, put the other one in. It's the same chip. Nope, same bloody thing. Okay. It's working fine. This side is not. So either chip has the same problem, but I don't think it's the chip. It's not this because it's still on and I took it out of the circuit. So it has nothing from here to there. It's all up here. I just eliminated this little branch here because I just disconnected it way down over here by taking this out. Because this goes here. So this isn't connected. So that's not connected. So this isn't connected. So that's not connected. So take out 203 and that should knock out 209, which is where bad things are happening. But if I take this out and it goes out, then let's see, this connects to branch here, which seems to be, and pin 2 is wrong. Already replaced you. Haven't I? Yep, already replaced this diode. Yep, not that. I replaced this. It's not that. I replaced this. It's not that. I replaced this. It's not that. Replace that and that. I can swap those, no problems. This is reading right on this side, not this side. So it's what 203 does. 203. You are my evil person here. Let's see. Maybe. I don't know. I'm beginning to wonder if I've lost my mind. So you are this one. Maybe I'll just pull. Well, let's go ahead. Let's take you out too. And this one. First, I have to resolder you. Resolder you. First, I need to resolder you. You're resoldered. You should not come on. And you came on. Holy crap. Well, at least now you're the right voltage compared to over here. You're still too high. What the freaking heck, man? Ow. Okay, I have disconnected you. So that pin, which is the input that this checks against. So again, here's the input. Let's check these again. So you should be on the high end. You are. You should be 0. You are. 5 should be 0. And you are. But as soon as I connect that, you won't be. So now the output, which is 2, is much smaller. No, it's not. Okay. 3 and 4. 4 is now that spurious result. 4. So 1, 2, 3. The capacitor. So R205. The frickin' heck, man. That's fine. That's fine. Why in the hell are you 4? How can you be 4 volts if that is 0? 3 is R205. 205 goes here, and then here, and here. That should be 7 volts there. 1, 2, 3. Okay, it's blue here, pink here. So I have to get you back on there. You have to go back up there. Then dark gray up top, light gray down here, and then these 2 black wires. This one, the right, goes on the bottom of that pin right there, and the longer one goes on the top pin of that one right there. And that'll be another day, because I'm tired. I don't want to do anymore. Okay, this is the schematic of the ADC Sound Shaper 2 MKII that I managed to dig up. It doesn't exactly match the circuitry on the board that I've been working on, but it's got me far enough. And I'll even point out some of the details on the actual board that are a little bit different. Okay, now, these are all the LEDs I am trying to fix. The ones you see marked here in red do not work. The ones that are marked in green do work, which is strange, but that's the way this is arranged. Now, I've been playing around and tracing all of what's going on here, and these are op amps that monitor the signal coming from the audio compared to a reference voltage. If the bottom of each op amp is 0 volts, the lights don't come on. If the voltage on the reference are all too high against what it's trying to monitor for,
they stay on. So if where it says 0 volts here is greater than the 1.1 volts it's looking for, it stays on. If this is greater than 0.7 volts, it stays on, and so on as we go down the array here or the array here. Now the difficulty in the LEDs that are staying on all the time is in the circuitry, it's reading too high everywhere. The problem arises because for the LEDs that stay on, the ones marked in red, the reference voltage that the op amp is looking to measure against are all too high, and they all stay on. So this one stays on, this one stays on, this one stays on, this one stays on, this one, and so on. So those LEDs stay lit. For the ones that are working, it drops to 0 after you turn it on, and then if it goes above, it turns on. If it goes a little higher in audio signal, it turns on. If it goes a little higher in audio signal, it turns on, and so on. But these ones marked in red are just measuring too high. Okay, in reviewing what I was explaining on this, I kind of got tongue-tied a little bit. So let me back up just a smidge here before you see the rest of this and say, okay, what's happening in this op amp array is essentially as you go down all of these op amps in the system here, there is a voltage set by the variable resistors, these guys on the high end and low end. And what it's looking for to illuminate the LEDs is to illuminate the top one, you need a really strong signal that gets above 1.1 volts. Go down 0.7 volts, go down 0.5 volts, 0.3 volts, and so on. And that's the reference voltage each op amp is looking for. Now on the input side, it's supposed to turn on and immediately go down to 0. And when a signal is processed through here, it's supposed to trigger and say, oh, you know, I've gotten a really loud signal. Let's turn on all of them. And the voltage gets above 1.1 volts, and all the LEDs turn on. If it's not as strong and it only gets above 0.7 volts, then all of the LEDs turn on except one, you know, and as I go down the scale, if the signal isn't as strong, these stay below, and so the LEDs stay off. But if the lower ones are above a certain reference voltage, like 0.3 volts, a few of them stay on. So it bounces up and down in the scale on the continuing array on op amps. And you can see here in the story is where I finally end up. So that'll be in a little bit of future here, because I'm breaking in the middle of explaining it once to say, hey, I kind of got tongue-tied. So here's the rest. So I've been slowly trying to work my way through the circuitry, fixing stuff. And now we can go to this, and you can see I've been doing my due diligence, trying to figure out the circuitry in each operational amplifier chips here, and they've got 2 op amps in each one, and half of it is for the left and half of it is for the right on each one of these. And then these resistor arrays set the reference voltage, and another one of these essentially waits to compare it to so that I know to turn the LEDs on and off. Now, I have carefully removed each op amp chip, measured each pin out and pin in, and it all comes down to pin 2, which is the signal in. This is the reference voltage, like the 1.1 volts or the 0.7 volts. And then another input, and here again is the reference voltage. So I thought at first, you know, are all of these chips bad just on one side? It didn't make sense, but I tested them anyway. So then I started going, okay, let's step back. Let's check some diodes that help do also switching. If I get a voltage that's too high, these turn on, and I get a reading that's too high. So where are all these operational amplifier chips and these resistor arrays that are looking at the audio signal levels controlled? Well, there's some variable resistors here and here for the kind of the high end. There's some down here for the low end. I'll have to adjust the signals on those so I can set the scale right later, but the problem right now is just fixing the scale. So you've seen green good, red bad. So again, on the outside of each one of these chips, and I have played chips back and forth, turned them around, done all kinds of things. It's not these chips. So it's something else elsewhere. At first I thought it was these resistors. No, I can flip-flop those all around the place. I can take them out, I can measure them, they're doing fine. So you start tracing with your multimeter and measuring where all these signals come from. And of course they go through some of these switches. So it reads high, you get over here, it's still reading high, you think, well, let's check the inputs. They seemed kind of fine following resistances. So I thought, okay, maybe I just have some bad switches and bypass or turning the meter on and off. Took these out, cleaned them up inside and out, took care of the oxidation, reinstalled it, Still got the problem. Okay, keep backing up. You end up over here where there's this chip, and you think, okay, with this chip, maybe it's got a problem. So we're now over here. What's it doing? Well, one channel is for the right side, one side is for the left side, and then you have to go through and figure out what each one of these pins is supposed to measure, and so on, and where the inputs are on your audio signals and ground and, you know, left and right channel. Okay, so you come through here and you make sure everything is getting through, and it's fine. So you slowly wormed your way over here and you start going, okay, hey, that's measuring wrong. Let's check this resistor on the other side. Still wrong. Something's wrong with this resistor. It shows the same voltage on either side, which kind of makes sense, but also kind of doesn't. You go over here to the capacitor and you measure what's going on with it, and it measures bad, so you replace it. And then you come back over here to the resistor and you notice if you take it out or put it in, it definitely turns all the diodes off. All of the LEDs are off. Okay, so problem exists over here somewhere on this side. You take this resistor all the way out, you measure it, and you find out it's not right. Something's wrong with it, so you replace it. Great. You think that's going to fix it? No. Okay. You press on. You keep comparing this side of the chip's measurements to this side of the chip's measurements, because everything over here and all its branching networks are fine. So you come over here. You find this capacitor bad. You replace it. I actually come over here. I find that capacitor bad. You replace it. There's a diode here. There's a diode here. You start measuring these diodes and making measurements across them. You find out this one's bad. You replace it. You notice that the little diode tied to the resistor on this side and the diode tied to the resistor on this side behave differently. I can take my finger and touch this side and the signal goes up and down. I touch the little system over here and nothing. Just stays pegged all on. So I think, okay, let's just play a game. Let's swap this side with this side for those two. And then you find out that didn't fix it. Great. What I'm slowly narrowing down to is there's a problem with this chip. Or is there? Eventually I decide it's the chip. There's something wrong with the chip. These voltages that is trying to be compared and run through this IC chip aren't right. So great. You look at the part number and you order some more. You pull out the old one, you put in the new one, and the problem is still there. So what you thought was the chip isn't the chip. You keep going. You start replacing another piece. You start replacing another piece. And then you think, okay, maybe it was the chip and the one you took out had a problem. And then when you put in the new chip, you blew it too. I didn't. Turns out whatever chip I put in here is fine. So you go back to basics. You start looking for things here and measurements in your circuitry that don't match. And the good part is you have one side that doesn't work, you have one side that does. Very methodically, piece by piece, resistor by resistor, instead of shotgunning it, thinking, oh, it's got to be this and replacing it. Oh, it's got to be that and replacing it. You just slowly start going through. Eventually, I recapped everything. Everything's been recapped, because why not? Especially over here in the power area here, everything here was way out of spec anyway. It actually did help. Once I had all the capacitors set, you could turn on the system and the LEDs would peg straight up, but eventually come down. That was actually a good sign. It was the first time I got the left LEDs to come down after turn on. It took a while, but after about 30 seconds, it dropped. So that told me the input voltages on each side of these was suddenly dropping to 0. I just had to figure out why. Okay, here we come to the switches. You think, okay, maybe something's weird in the switches. There's a spot. You play around with those. No, you clean them up anyway. Then you start looking at your circuit board compared to the schematic you have. It's all you got. You keep going back and forth and back and forth and back and forth. And you slowly begin to notice a few differences. Let me show if I could show you. Up here, you'll notice a bunch of the things I've changed, you know, capacitors, some of the resistors, more capacitors, resistors that were measuring bad. I actually got so fed up with this, I installed sockets on all the ICs so I could pull them and plug them in, pull them and plug them in, back and forth and back and forth and back and forth, and play around. Again, cleaned everything, banging my head against the wall. What finally happened? Notice these 4 resistors here, 1, 2, 3, 4. 1, 2, 3, 4. There's only 2 in the schematic, 1 here and 1 here. Where are these? Where are these? I've got some resistors here that appear, but these inner resistors that this have don't appear here. Some of these boards were made in different places. Some of these were made in Taiwan, some were made in Japan, apparently some were made in Malaysia. So there's slight differences between any schematics I was able to find. These resistors appear on the schematic down here. This capacitor is in the right place, and so you keep going back and forth. You replace, you get closer to the measurements you want. You replace, you get closer to the measurements you want. Again, everything over here is working. Everything over here is getting closer. And I finally narrowed it down to these two resistors. You notice they're still the original one, but those two right there in this little scenario turned out to be something going on. Come back over here, and it turned out to be literally a cold solder joint. It looked fine. I measured resistance. You did all kinds of things, but as soon as you got there, something was wrong. It just wasn't working. So I reflowed it. I reflowed that one resistor. It never looked wrong. It never measured kind of strange, but it was definitely not behaving correctly. But as soon as I reflowed it, and let me tell you, this thing measures fantastically now. The LEDs worked. I can't tell you what a pain this was. But the things you see replaced were definitely out of spec. All the capacitors were horribly not measuring right. They had ESRs that were way out of spec. The chips turned out to be fine. It just turned into a collection of many multiple problems that kept getting me closer and closer and closer until I could narrow down to a solder joint that looked fine. It wasn't. And now everything is working as it should. Now I just have to put it back together and finish cleaning it up and make sure I don't electrocute myself in the process, because doing this little maneuver is not the smartest, but at least I know this circuitry so well. I know if I touch that resistor right there, the chip is sensing it, and then the op amps are going, hey, I got some voltage there, I got some sort of information, and then I can display audio levels. Now I just have to start putting this thing back together and make sure it works. So let's start to do that. Which apparently is going to be easier said than done. Okay, here is the cleaner front that I now have to somehow get on. Carefully. And the first thing to do will be to align all those and screw that in. Looks like everybody is okay. Just be careful. To have had feet. Let's see if I can't find feet. Please don't explode. Yay! Thank the Lord Jesus. That was a long story. Ah. Oh, it's down there. Dirt. Everything is always a problem. Cleanup montage. Lots of fingers have touched these over a long period of time. I really got to scrub on each one, up and down. Why is my camera misbehaving? I don't like that. Oh, screws. I'm missing some screws. Okay, been thoroughly cleaned inside and out. Rebuilt pretty much on the inside. Bunch of failing components taken care of. It has a chip of all things that's new. Got 2 more of those. So this thing is, oh yeah, I still got to calibrate it. Yeah, I'll take the top off again and calibrate it. Okay, time to do some calibrations. Pin 3 on this one is supposed to read 1.1 volts, which is pretty close. If I twist you down, you go down. If I twist you up, you go up. So let's get back to 1.1 volts. Touchy little thing. Good enough. Okay, the next one is supposed to be 0.7 volts. So here, 1, 2, 3. That's pretty much 0.7. And then it's supposed to be 0.4 on the next one. And it's a little high, but pretty close. Then 0.3. Pretty much right on. Then we sneak over here to the other side. And now we're supposed to be, let's see, I'm on the outside now going up. So 1, 2, 3, that one. That one is supposed to be 0.2. No. That was a little low. Let's see this one. Wait, what? Oh, I'm going the wrong way. Okay, hang on. It's going up this way. So 1, 2, 3. Yeah, 0.2. Then 0.1, or close to half of that, 0.1. 5, and then 0.1. Okay. So hang on, I need to do the low end. Okay, so the low end is this one. So, okay. Make sure I don't want to keep myself here. 1, 2, 3. And I think it's this one. Yeah. So you're supposed to be close to nothing. Right? 0.65 millivolts. Okay. That would be 0.6667. Back the other way a little bit. If it lets me. Okay, that's close enough. So 0.65, and then about 0.1. Yep, and then about, see, that one's supposed to be closer to 0.2. Get to play back and forth games here. Then this one is, wait, 1, 2, 3. You are supposed to be 0.3. You are supposed to be 0.4. You're right on. You're supposed to be, oh, wrong one. So 0.7, and you're 1.1. Okay, so up a little. Here we go. Here we go. Here we go. Here we go. And on the low end. There we go. There we go. And this should be 0.65. Yeah. Okay. Now let's go the other side. So it should be 10, 5. Yeah, 5. So pin 5. I can't count. Wait. 1, 2, 4. Pin 5. So you're supposed to be 1.1. No, that's 9 volts. That was the wrong one. 1, 2, 4, 5. Pin 5. That's this one. Having trouble counting today. The other way. So 1.1. So I need to turn you down a smidge. No, up a smidge. Other way. Close enough. Okay, then 7, cool. Then 4, then 3, yep. 10. So you're gonna be this one. 2, ooh, this is gonna be right on. 1, that's a little high and low end. And then you here. Yeah, you're a little high and low end, so I need to go and go. Okay, I'm not gonna stress over 1 millivolt. This should be close to 1. You are. It should be close to. And you are. Okay, we're good. We have got it adjusted. I don't actually hit it. We are fine and dandy. You're on, you're clean, you're functional, you're rebuilt. We can put the top on you and we'll be done. Then we can do a cleanup and a video.